Good day, future engineers. Welcome again for our next discussion on our dynamics of rigid bodies. And for this time, we'll be talking about the absolute dependent motion analysis of two particles. So, sa maning absolute, what is absolute dependent motion analysis of two particles? Now, in a previous discussion of the dynamics of rigid bodies, di ba, we are only considering a single particle moving along a straight line or moving along a curved line. And now this time we'll be analyzing two particles that are moving or that are in motion. And what is this analysis of the absolute dependent motion analysis of two particles? Okay, so let's start for our absolute dependent motion discussion. So we have a figure here now. We have a material A and material B, or let's say a box A and a box B. Now, the box A and B is connected by an extensible cord. So, see A and B is connected by a cord. No, no, it is connected by a PC. By PC, there is a cord connecting them. So now what happens if A moves or B moves? So here, as you can see, if, just in case, if A moves to the left or downwards, B moves upwards along this inclined surface. And if B moves downward, A will move upward. So this is the absolute dependent motion. One particle is dependent uh, on the motion of another particle. So that's why it's an absolute dependent motion analysis of two particles. Now, we call this the relative motion. It means that the motion of a particle, let's say that the B moves down, obviously A will move up. So it means that relative to B, moving downwards, A will move up the inclined plane. So mo ni siya to ang absolute dependent motion. So we're just going to relate this in our previous discussion. No? In this topic also, we'll be dealing also again with velocity and also with acceleration. So if you notice, no, we have S sub A and S sub B or SA and SB. So this denotes the distance or the length of the chord from our origin or the datum line. So unsa may first na buhatan when you are dealing with absolute dependent motion analysis of two particles. First is that you establish an origin. Let's say which will be our datum. And from that, perpendicular to the chord and to be extended sa tuang box A, we will have length SA. And from the origin again, and perpendicular to the chord, and once siya extend towards our box B, then we'll have our length SB. And you also have here, kanina kared gani dira here, that is part of the length of the chord. So sa may button na to ani, in this type, no, there is a dependency, no, that occurs between two particles. So what we're gonna do with this one is that we will write the total length of the, we'll form an equation of the total length of the chord. For this one, let's say, L symbolizes the total length of the chord. So the total length of the chord for this example from A to B is just equal to the length of SA plus this one, the length of CD plus the length of SB. So may next na to buhaton, what we're gonna do next? We try to differentiate this whole equation to the first time derivative, or we just differentiate this with respect to time. So we have a derivative of the length with respect to time is equal to derivative of SA with respect to time plus derivative of the length CD with respect to time plus the derivative of SB with respect to time. Now, what is the derivative of the length of the chord? If you notice, no, along the motion of these two particles, the length of the chord remains constant. So whatever the case, whether A will move up or down the inclined plane, or whether B moves up or down along the inclined plane, the total length of the chord remains constant. And we know that the derivative of constant is equal to 0. How about the derivative of SA? So the length SA, derivative, as we know that SA, if these particles or these two motion is moving, we know that the SA changes. So we, since this is a position and then it changes through time, then this means that this becomes our velocity or the velocity of the A plus the derivative of the length CD with respect to time. Now the derivative of the length CD. Now we know that the length CD also remains constant through time. So that is also equal to 0 because the derivative constant is equal to 0. And here we'll have the derivative of B. So here only remain with 0 is equal to the velocity of A plus velocity of B, or simply the velocity of A is just equal to the negative velocity of the B. So this is the analysis of the absolute dependent motion of two particles in motion. So unsa may purpose ani what why the velocity of the A is equal to the negative velocity of the B? So it just represents the direction of the velocity of B. So if the velocity of A is moving upwards along this inclined plane, negative means it represents the opposite. So it means that B is also moving downward along the inclined plane. So yun na siya kasimple. Now, if we differentiate further this, no, the velocity with respect to time, then we'll come up with the acceleration of A is equal to the negative acceleration of B. How about with this one? This is a very complex example. Before to example earlier is very simple. And how about this one? Are you gonna solve this a specific example? So again, first you need button is you need to find an origin or a datum line. So generally atong datum line diri is that kanina diri sa ibabaw. So from this point, so ato ang ginabutang og datum line is atong length na dili ka change. Kanina ka red nga portion gani diri, it represents lengths that are constant along the motion of these two particles. So this remains constant. And also this one. So sa may buhaton na to ni. So again, first, let's write as the total length of this specific problem. We have the total length of the chord is equal to, now for the vertical line, atong datum is here, and then it moves downward. And for horizontal, because this block here is moving towards, let's say it moves towards the right, of course. Then we'll have our datum line here, and then it extends outward to the right. So for this one, we have the length. The length of the chord is equal to the length of SA plus the length H this one, plus we have here an SB. This is SB. This is also SB. So that is 2SB. Now we differentiate this whole equation with respect to time automatically. Since the length of the chord is constant, that becomes 0. We have 0 is equal to the velocity of A plus what is the derivative of our h with respect to time. So if you notice no, that our h here will what? Our h here will remain constant throughout the motion of these two objects. So that will become 0 also. And plus 2 times velocity of B. So from this one, we can arrive that the velocity of A is equal to the negative twice the velocity of B. And that the acceleration of A is equal to negative twice the acceleration of B. Now, so we can understand this more clearly, let's proceed with our first example. So here we have two moving particles or objects. For us to find or to determine the speed of block A, if block B is an upward speed of 6 foot per second. So don't forget the units, no? Isay mo wala ta. So sa may buhaton na to ni, it's just write the total length of the chord is equal to. So we have here this is our established datum line, and then downwards we have the length SA plus sa may naa, the length here plus this one plus this one. So these three lengths are equal. They are length SB. So ato lang siya isulat as 3SB. So nganong wala na to giapil ang uban? Because the rest of the length of let's say this one, the length here and the length of this curve, they remain constant along the duration of the motion of these two blocks. So since they are constant, if you differentiate that, that becomes 0. Now, if we differentiate this length with respect to time, we will have 0 is equal to the velocity of A plus 3 times velocity of B. Now, we were asked to find the speed daw kuno ni block A. So, block A, the speed of block A is just equal to negative 3B. You just substitute the speed of our block B, that's negative 3, times the speed of block B, which is 6 foot per seconds. So the velocity of A is equal to negative 18 feet per seconds. Now, our negative sign now is that shows the direction of our velocity. Since the velocity of B is moving what? That moves upward. Therefore, our velocity A is 18 feet per seconds and is moving downward. So this is the speed of block A if block B has an upward speed of 6 foot per second. So muna to siya, no? First, we write the equation of its total length, and then we differentiate that with respect to time. That's why we arrive with this one. The derivative of the length is 0 because the length of the chord along the motion of these two particles remains constant. And also, we didn't include the length of these other parts because they remain constant along the duration of the motion. And dugang-dugang lang siya nga pag-sabog sa ato ang solution, no? Because in the end, we just differentiate the whole equation, the length equation, with respect to time. And then they will just become, or they will be equal to 0 because they are constant. So muna itong gisulat is those lengths that are changing, like the SA and the SB. Okay, for our second example, we have here determine the speed of block A, let's say of A, if B has an upward speed of 6 foot per second. So this is quite similar with the first one, but notice the difference. The first one has only one chord. Here we have two chords. We have this chord and we also have this second chord here. So say may buhaton na to anak. First, we just di lang to matalanta. We just calm ourselves and okay, let's start solving. So let's say no this chord here will be our length 1. So the length of the first chord is equal to, we have the SA, length SA, plus what? Plus the length of this one. And also this one. So what is the length of that one? So these two here has an equal length. Now, if you look at it, and then the length of that one is equal to SC. Since duha sila kabuo, that is 2SC. And then if you differentiate that with respect to time, we'll have 0 is equal to velocity of A plus twice the velocity of C. Now our let's write our length 2. The total length of our second chord is equal to, so let's start from ano yung pinakataas first, pwede ito malibog. So we have SB plus, what else do we have? This chord here, the length of this chord. So it also changes. So saan mo na ito napagkuha? So, klaro kayo no, we have here the length SB, and then if we subtract the length SC, then we'll be able to determine this length. So that is just equal to plus SB minus SC. Or simply that our total length of our chord 2 is equal to 2SB minus SC. And if we differentiate that with respect to time, we'll have 0 is equal to 2 times the velocity of B minus velocity of C. Now, we were asked to find the velocity of A. So, solve na to na. So, we just equated with our velocity of C. Velocity C is equal to twice the velocity of B. We just substitute this one here. Then we will have 0 is equal to the velocity of A plus 2 times 2 times velocity of V, or 0 is equal to velocity of A plus 4 times velocity of B. Then, transposing, we'll get the value velocity of A is equal to the negative 4 times velocity of B. And then we just solve that one. We have the velocity of B that is moving upwards at 6 feet per second. Then we'll have negative 4 times 6 feet per second. So our velocity is equal to negative 24 feet per second. Or simply, that our velocity A is 24 feet per second, but is moving downwards, as denoted by the negative sign. So it means that it moves opposite to the direction of our velocity B. Since velocity B is moving upward, and we have a negative sign, therefore velocity A is moving downward. Kung opposite po na siya, if the velocity B is moving downward, and we have a negative velocity of B, then VA is understood to be moving upwards. So that is quite simple lang, no? Now for a third example, determine the speed of B in the end of the chord if the end of the chord at A is pulled down with a speed of 2 meters per second. So in this case, no, the other end of the chord is being pulled at 2 meters per second. So again, if you notice the drawing, we have two chords here. So we need to write two length formulas for each of the chord. So we have our length one, total length of our first chord. So let's say ito ang our first chord is this one. No, not that one. Yeah, we have this one. So no, this one. We have this one. So if you look clearly, so we have here, we have our datum here, and then downward we have length SB. And how about this one? Pila ni siya nga length. So if you extend that one, that is from the datum line, so we know the I that this one, the length here, is just equal to, this will be SC, and then you're finding the length here for this one. So that is just equal to plus the SB, the length of SB minus length of SC. What else do we have? The remaining one here. So what is the length of this one? So if gikan sa datum line downwards, we have SA, and then we have here from the datum line and then downwards, we have SC. So the length of that one here is just equal to plus the length of SA minus length of SC. That is just equal to, we just combine like terms, we'll have SA plus 2SB minus 2SC. And if we differentiate that with respect to time, we'll have 0 is equal to the velocity of A. That is just equal to the velocity of A plus twice the velocity of B minus twice the velocity of C is equal to 0. How about for the length of our second chord? The length of our second chord is no from gikan magabo na siya gikan this origin paingon dili. Now we need to get this whole length because from this point or from this origin to this point, this length also changes. So this it's already, even though this part is already not part of the chord, then but we need that one because this whole length here also changes uh, as the block or these objects is moving. So that is let's say the length of that is just SB, and then we need to get the length here. So if you note that we try to get the length from the datum to another datum and to another datum. So that is just the SC. So we'll have plus SC. And if we differentiate that with respect to time, we will have the velocity of B plus velocity of C is equal to 0. Now let's say what we're going to do next. We have we need to find the velocity of B, and we are given the velocity of A. So we need to remove a redundant here, that is the velocity of C. So by this one, you know that the velocity of B is equal to the negative velocity of B. The velocity of C is equal to negative velocity of B. Then we just substitute that one here. Ito lang yung more redundant because ito among lead ko is the velocity of B, and then we already have the velocity of A. So, substituting that equation here, we'll have velocity of A plus 2 times the velocity of B minus 2 times negative velocity of B is equal to 0. We'll have velocity of A plus twice the velocity of B plus twice the velocity of B is equal to 0. And we'll have the velocity of A plus 4 times the velocity of B is equal to 0. Therefore, the velocity of B is just equal to negative velocity of A over 4. And then the velocity of A is equal to 2 over 4, that is equal to negative 0.5 meters per seconds. Or simply that the velocity of B is equal to 0.5 meters per seconds. And since we have a negative sign here, it denotes that the motion of our B is opposite to the motion of A. Since A is moving downward, then the motion of B is moving upwards. And that will be the final answer for this specific problem. Now let's move to our final example for this topic. We were asked to find or to determine the velocity of D, so this one, if the of end A of the rope is pulled down with a speed of 3 meters per second. So if you notice, there is only one cord. So again, first into button is we establish that datum lines, and then that should be from the center of these pulleys. Also here we have a datum line here. That's this one. On this side also we will have that one. So let's say that length is SA, and the length on this side is let's say SD na lang because so we'll have our velocity at T, so that the markings are just related to what is being asked. So the total length of this cord is equal to, so from left to right, we have SA plus, so as this object or this system moves up or down, these three lengths here will be equal along the motion of these two particles. So that is just equal to SD or 3SD. Use the differentiate that respect to time, we will have velocity of A plus 3 times velocity of D is equal to 0. And since we're asked to find the velocity of D, then we will have the velocity of D is equal to negative velocity of A over 3. And we have the velocity of A is equal to 3 meters per second downward. So we'll have negative 3 over 3 is equal to negative 1 meters per seconds. Or simply that the VD or the velocity of D is equal to 1 meters per seconds. And since we have a negative sign here, that means or it denotes that the motion of our D is opposite to the motion or to the direction of the motion of our A. Since A is moving downward, then D is moving upwards. And then that will be our final answer for this